Hello, I'm Francesco Tonini from the University of Trento, and today I am excited to present our paper titled Object-Aware Gaze Target Detection. So let's begin with a brief overview of the task. In gaze target detection, the goal is to predict where people are looking within an image. And traditionally, methods typically predict a Gaussian heat map centered on the gazed area. And although these methods have yielded impressive results, they lack the ability to determine precisely what object, if any, a person is focusing on. And therefore, we introduced a novel approach to gaze target detection, one that not only predicts where a person is looking, but also identifies the specific object they are gazing at. Here is an overview of our complete network for object-aware gaze target detection. We begin by employing an object detection transformer to identify and classify objects and people's heads within the image. Then, we predict a gaze vector and a gaze cone for each person. And if that data is available, our network can be trained to predict a 3D gaze vector, which enables us to calculate object scores within a 3D gaze cone. We can think of the gaze cone as a person's field of view, allowing us to identify the objects they are most likely looking at. All object scores are then aggregated into the object score matrix, which is then used by the gaze object transformer module. With all the information about which objects are present in the scene and the corresponding gaze scores, we model the relationships between each head and object pair. This modeling is accomplished using the gaze object transformer, which utilizes the object score matrix as an attention bias. Finally, we predict a gaze heat map for each person in the scene using the features from the gaze object transformer. And importantly, if no objects are present in the image or within a person's field of view, we can still predict a gaze heat map using head features only. We tested and evaluated our method on popular datasets for gaze target detection, including gaze follow and video attention target. To assess our method's performance and compare it to previous state-of-the-art approaches, we measure the gaze heat map area under the curve, the average Euclidean distance between predicted and ground truth points, and the probability of correctly detecting out-of-frame gaze. Here's a comparison of our method against state-of-the-art techniques on both gaze follow and video attention target. Notably, our model achieves state-of-the-art results on both datasets, with a 1% improvement in video attention target when depth data is available. And when we evaluate the average and minimum distances between the heat map peak and the ground truth gaze points, our method achieves up to a 45% improvement in both minimum and average distances using the 2D cone, and when we move to the 3D cone, the results improve by an additional 2%. Considering the low consensus among annotators in gaze follow, we also evaluated the robustness of our method across varying levels of variance. And as we can see, our method outperforms previous approaches in all variance scenarios. In conclusion, our method excels in predicting where a person is looking, and importantly, which object they are gazing at. Even in scenarios when our object detection transformers fails to identify objects, our method remains versatile and robust, continuing to predict the gaze heat map. Thank you for your time. The source code for the project and the paper are publicly available on my GitHub profile.